The story begins not with a stroke of strategic genius in a war room, but with a chaotic accident in the midst of a gale. In September 1940, the English Channel was whipped into a frenzy by fierce winds that battered the southeastern coast of Britain. At this stage of the war, the British coastline was dotted with massive barrage balloons, large hydrogen-filled hulks tethered to the ground by steel cables intended to foul the propellers of low-flying Luftwaffe bombers. However, nature proved to be a more immediate adversary than the Germans that night. The storm tore the balloons from their moorings, sending these unmanned, massive rubber bags drifting eastward into the darkness. They floated silently across the North Sea, ghosting over the water until they reached Scandinavia. Within hours, strange reports began to filter back to London through neutral diplomatic channels and intelligence networks. In Sweden, power grids were flickering and failing. In Denmark, a radio station antenna had inexplicably toppled over. In Finland, electrical fires were breaking out. It was a bizarre series of anomalies that could have easily been dismissed as the coincidental collateral damage of a storm. To most observers, it was merely a nuisance, a loss of British equipment that had accidentally inconvenienced neutral neighbors. However, inside the British War Cabinet, specifically within the keen mind of Winston Churchill, these reports sparked a different realization. The Prime Minister, reading the damage assessments, realized that a handful of runaway balloons, costing almost nothing and devoid of pilots, had achieved what the Royal Air Force was struggling to do with millions of pounds of equipment and thousands of lives. They had crossed enemy lines and physically dismantled infrastructure without dropping a single explosive. Churchill, with his characteristic flair for turning disaster into opportunity, issued a memo that would birth one of the most unusual weapons of World War II. He suggested that they might make a virtue of our misfortune. If an accident could cause such chaos, a deliberate campaign could cripple the enemy. Thus, Operation Outward was born. To understand why this idea was so revolutionary, one must understand the desperate context of 1941. Britain was standing alone against a Nazi empire that controlled most of the European continent. The primary offensive tool available to the British was RAF Bomber Command, but the reality of the air war was bleak. The strategic bombing campaign was failing to deliver the knockout blow that planners had promised. The cost of these raids was astronomical, both in treasure and in blood. A heavy bomber like the Avro Lancaster was a marvel of engineering, but it required a crew of 7 highly trained men, pilots, navigators, bombardiers, and gunners. Every time a bomber was shot down over Germany, Britain lost not just an expensive machine, but years of accumulated training and human experience that could not be easily replaced. Furthermore, the accuracy of night bombing in the early 1940s was woeful. Navigation systems were primitive, and bombs often fell miles from their intended targets, scattering across fields rather than hitting the factories that drove the German war machine. German industry, particularly its electrical infrastructure, was a tempting but elusive target. The Third Reich was powered by a massive, interconnected grid of generating stations, transformers, and thousands of miles of high-voltage transmission lines. The vulnerability of this system was its connectivity. If you could damage the grid in enough places simultaneously, the power flow would become unstable, leading to cascading failures that could black out entire regions. However, achieving this with conventional bombers was nearly impossible. Power pylons are thin, skeletal structures that are invisible from 20,000 feet at night. Even generating stations were relatively small targets compared to the sprawling cities that the RAF usually resorted to carpet bombing. The British needed a way to attack the web of wires connecting the German economy without risking their precious heavy bombers. The solution, championed by Captain Gerald Bannister of the Boom Defense Division despite initial skepticism from the Air Ministry, was to weaponize the weather itself. The weapon that emerged from the planning stages in September 1941 was a masterclass in frugal engineering. It was the antithesis of the heavy, over-engineered German military machine. The British utilized standard Royal Navy meteorological balloons, roughly 8 feet in diameter when inflated. These were not new inventions. There were nearly 100,000 surplus balloons sitting in warehouses, preserved in French chalk, essentially useless for their original purpose, but perfect for this new form of asymmetric warfare. The balloons were filled with hydrogen, enough to lift about 18 pounds of payload, and released to drift on the prevailing westerly winds that blew from Britain across the North Sea toward Germany. The genius lay in the cost. Each balloon, including the hydrogen and the payload, cost approximately 35 shillings, roughly 2 pounds in the currency of the day. The payloads were designed to inflict maximum disruption for minimum cost. There were 2 primary types, designated wire and incendiary. The wire payload was a weapon of electrical sabotage. It consisted of a trailing line of hemp cord attached to hundreds of feet of steel piano wire. As the balloon drifted over the continent, it would slowly descend due to a leak mechanism or a timed fuse. The wire would drag across the German countryside, snaking over fields and forests until it inevitably encountered the high-voltage transmission lines that crisscrossed the nation. When the steel wire made contact with 2 different phases of the power line simultaneously, or bridged a live line to the earth, it created a massive short circuit. These were not minor sparks. They were violent electrical arcs capable of melting aluminum conductors, blowing out transformers, and tripping circuit breakers across the grid. The incendiary payloads were designed to exploit the vast pine forests and heathlands of Germany. These included socks, which were canvas bags filled with wood wool and paraffin wax meant to catch in the crowns of trees and burn intensely, and beer payloads, which consisted of bottles of self-igniting phosphorus. There were also jelly canisters that created large fireballs. The mechanism for deploying these weapons was governed by a simple but ingenious altitude control system. As the balloon rose into the thinner atmosphere, the expanding gas would tighten an internal cord, opening a spring-loaded valve to release hydrogen, causing the balloon to settle into a drift altitude. A slow-burning fuse, calibrated to the wind speed and the distance to Germany, would eventually release the payload or destroy the balloon. The operational concept relied on volume. Precision was unnecessary when you could flood the enemy's airspace with thousands of floating saboteurs. The execution of Operation Outward fell largely to the Women's Royal Naval Service, known as the Wrens. At launch sites like the one disguised at the Felixstowe Ferry Golf Club, or later at Old Stairs Bay in Waxham, hundreds of women worked in dangerous conditions to launch these silent weapons. Handling hydrogen is inherently perilous. The gas is highly explosive, and the friction of expanding latex can create static electricity. The Wrens worked inside three-sided shelters, constantly spraying the balloons with water to suppress sparks. They wore specialized flash gear, including fireproof hoods with copper gauze veils and protective heavy gloves. It was grueling, repetitive, and terrifying work. Yet, despite the risks, the crews became terrifyingly efficient. At the peak of the operation, a single site could launch hundreds of balloons in a matter of hours, creating a veritable armada of rubber spheres drifting toward the enemy coast. The launch windows were dictated by the weather. The operation required westerly winds at altitude to carry the balloons deep into Germany, and surface winds in the target area to ensure the trailing wires would drag effectively. Fortunately for the British, the prevailing winds favored them about 55% of the time. Conversely, easterly winds that might have allowed the Germans to retaliate with similar balloons occurred significantly less often, giving Britain a natural geographical advantage in this aerial duel. The Wrens, keenly aware of the nature of their work, developed a dark sense of humor about the operation. Many veterans later recalled writing insults directed at Hitler or high-ranking Nazis on the uninflated balloons, messages that would stretch and become enormous billboards of defiance as the balloons expanded and drifted over occupied Europe. When these balloons arrived in Germany, the chaos they inflicted was disproportionate to their humble origins. The first launches in March 1942 immediately yielded results, with intelligence reports confirming forest fires near Berlin. However, the true devastation came from the wire balloons attacking the power grid. On July 12, 1942, a single balloon, drifting silently and unseen, achieved a victory that would have cost a squadron of bombers dearly. Its trailing wire struck a 110 kilovolt transmission line near Leipzig. The resulting short circuit was a phase-to-phase fault, a type of electrical surge that German circuit breakers were ill-equipped to handle quickly. At the nearby Bohlen power station, the massive sudden load imbalance caused a violent reaction in the turbines. The failure at Bohlen was catastrophic. The circuit breaker failed to trip in time, causing one of the massive 16.5 megawatt generators to lose synchronization with the grid. The physics of rotating machinery are unforgiving. When a generator falls out of step while still fully energized, the mechanical forces are immense. The rotor shaft bent under the strain, tearing into the stator and triggering a massive explosion. The ensuing fire gutted the power station. In a matter of seconds, a 2-pound balloon had caused over 1 million pounds of damage and knocked out a significant portion of the region's generating capacity. This single incident destroyed equipment worth 5 times the entire budget of Operation Outward. It was the ultimate validation of the program's economic logic. The Germans were baffled and frustrated. They called the devices Storballon, or disturbing balloons. The attacks were random, silent, and incessant. Between March 1942 and January 1943 alone, there were over 500 major interruptions on high-voltage lines. The damage to the lower voltage network was so frequent that German authorities eventually stopped recording the incidents. It was simply too depressing to track. In occupied France, thousands of power cuts were attributed to the balloons. The disruption went beyond just the lights going out. Every power outage halted production lines, stopped trains, and silenced communications. Sensitive industrial processes, particularly in chemical and metallurgical plants, were ruined when the power fluctuated. The harassment forced the Germans to maintain standing repair crews, keeping men away from the front lines, and to deploy fire watchers across the countryside. The German military response to Operation Outward was a case study in futility. Initially, the Luftwaffe attempted to shoot the balloons down. Fighter squadrons were scrambled to intercept the drifting spheres. In one documented instance, hundreds of sorties were flown in a single day to chase balloons. This was exactly what the British wanted. A Messerschmitt fighter burning high-octane aviation fuel and expending cannon shells to destroy a cheap rubber balloon was a net loss for the German war effort. It was an economic victory for Britain every time a German pilot took off. The balloons floated at altitudes that were difficult for fighters to reach quickly, and the targets were so small and numerous that traditional air defense was useless. Anti-aircraft batteries firing at the balloons were equally wasteful. expending valuable ammunition on targets that cost less than the shells being fired at them. The most damaging German response, however, was self-inflicted, born of panic and bureaucratic incompetence. Desperate to stop the power outages, a high-ranking Nazi engineer proposed a solution, a new type of clamp for the transmission lines. These clamps were designed to release the power cable if it was subjected to the unusual lateral strain of a balloon wire dragging against it. The theory was that dropping the line was better than burning out a transformer. With great urgency, over 1 million of these clamps were manufactured and installed across the German grid. It was a massive industrial undertaking. Unfortunately, the design was fatally flawed. The engineer had failed to account for the natural weight of ice accumulation in winter or high winds during storms. As soon as the harsh German winter set in, the clamps began to fail. Normal weather conditions triggered the release mechanisms, causing heavy power lines to crash to the ground all over the country. The protective measure caused more outages and damage than the balloons ever could have achieved on their own. Because the engineer responsible was a politically connected party member, it took months for the transmission authorities to gather the courage to point out the failure. Eventually, the Germans had to spend even more resources removing and replacing all million clamps. The British, oblivious to this specific success at the time, had inadvertently tricked the enemy into sabotaging their own infrastructure on a massive scale. The psychological impact of Operation Outward was also significant. It brought the war to the German home front in a way that was unpredictable and spooky. There was no air raid siren, no drone of engines, just a sudden flash of light, a fire in the woods, or the lights going out in a factory. It created a sense of pervasive vulnerability. Reports from the time indicate that the harassment forced the Germans to shut down power lines preemptively when attacks were suspected, which achieved the British goal of stopping industrial production just as effectively as actually destroying the lines. The resource drain was constant: fuel for fighters, manpower for repairs, and the mental energy of constant vigilance against a silent, drifting enemy. It is worth comparing Operation Outward to the Japanese Fugo balloon campaign later in the war to highlight the British success. The Japanese launched thousands of elaborate paper and silk balloons toward North America. These were engineering marvels, utilizing complex barometric sensors to drop sandbag ballast and ride the jet stream across the Pacific Ocean. However, they were expensive and largely ineffective. They killed 6 civilians in Oregon, but caused negligible strategic damage. The U.S. government simply censored the news, denying the Japanese any knowledge of their arrival, and the program fizzled out. In contrast, the British program was cheap, crude, and devastatingly effective because it targeted a dense, vulnerable infrastructure over a shorter distance. The British understood that the goal wasn't engineering perfection, but economic asymmetry. By the time Operation Outward wound down in 1944, not because it wasn't working, but because the hydrogen was needed for the invasion of Normandy, nearly 100,000 balloons had been launched. The total cost of the program was roughly £220,000. Post-war investigations by British electricity experts sent to Germany revealed that the balloons had caused at least £1.5 million in direct damage to the electrical grid, and likely much more in lost industrial production. The ratio of cost to damage was unparalleled in the history of warfare. Military analysts later equated the damage inflicted by the balloons to the loss of a capital ship, a battleship or aircraft carrier. Yet it had been achieved without the loss of a single British service member in combat. The operation remained a secret for decades, overshadowed by the heroic narratives of the Spitfire pilots and the heavy bomber crews. Yet, it stands as a testament to a different kind of warfare, the war of the intellect, of improvisation, and of economic leverage. It proved that a weapon does not need to be high-tech to be effective. Sometimes, the most dangerous weapon is not a guided missile or a heavy bomber, but a simple idea executed with persistence. The image of a latex weather balloon, costing a few shillings, drifting silently across the North Sea to humble the mighty industrial complex of the Third Reich, remains one of the most poignant ironies of World War II. It was the ultimate expression of British wartime pragmatism, a program that literally turned hot air and string into a strategic victory. In the final analysis, Operation Outward teaches a lesson that is often forgotten in the age of billion-dollar defense budgets and hypersonic missiles. The British realized that the enemy's strength, their complex, interconnected, high-tech infrastructure, was also their greatest weakness. By attacking the connective tissue of the German economy with a weapon so cheap it was essentially disposable, they bypassed the enemy's defenses entirely. The Luftwaffe could shoot down a Lancaster, but they couldn't shoot down the wind. They couldn't arrest a balloon. And as the German high command watched their power stations burn and their grid collapse under the weight of piano wire, they were forced to confront a maddening reality. They were losing the technological war to a child's toy. The legacy of those 100,000 balloons is a reminder that in war, as in life, it is often the simplest solution that strikes the hardest blow.